Really here for variation. Okay, so first off, we want to talk about like what is variation, right? So a variation for something that changes, like the word varies, it describes a special relationship between the variables x, y, and sometimes z. Technically, you can have any kind of different variable put in there depending upon the problem and the type. But what's key is the type of variation, okay? So really, we're going to look at three different types of variation. So we'll look at one at a time in terms of both what their equation looks like, what the graph looks like, what the words represent, and then how we would work a problem out based on that equation. So for direct variation, it would be y varies directly with x, and it could be y varies directly with x squared or the square of x or some other deal, but it varies directly. You're going to see those words in there. And what that's going to mean is that the equation base is y equals k times x. And k is our constant of variation. Okay, so for instance, you could have y equals 2x, and then anytime you need an x value, you could substitute it in, multiply it by 2, and you'd get the y value. Okay, you can also get the y value and then be asked to find the x, and you would divide by 2. So that k is that constant, or basically the number that allows you to compare the x and the y in terms of their variation. And the graph for direct variation is going to be a straight line, so that slope is constant, kind of like the way it would be for a linear graph. And it must go through 0, 0. So it has to go through the origin. So when x is 0, y must also be 0. All right, so let's look at an example of what that would look like. Suppose z varies directly with the square root of x. Okay, so first off, you want to write the direct variation equation using only the variable. So z varies directly. So we're going to write here z equals, and then you always need that k value for the constant. So z equals k, and then it said with the square root of x. So then we have the square root of x. So that's what you have here. Z equals k square root of x. Okay, next, it's going to give us a scenario. So it says when z is 14, x is 16. Then it asks us to find the value of z when x is 64. Well, first thing we need to do is plug the z and the x values in where we see them in here. So z is 14, we put it in for where z is. X is 16, we plug that in where the x is. And now we're going to go ahead and just do what we need to do to solve for k. Well, the square root of 16 is 4, so you get 14. 14 equals k times 4, divide both sides by 4, you get k equals 3.5. So that's our constant of variation that we had to solve for. And now we're going to rewrite the equation that we initially had, the z equals k square root of x, over again, but with the 3.5 as the k, since we just found it. So now our equation is z equals 3.5 square root of x. And now we need to substitute in what it tells us. So it says find z, so we're not going to know the z when x is 64. So you're just plugging in or substituting the 64 for the x. So now you do 3.5 times the square root of 64. The square root of 64 is 8. 8 times 3.5. Z equals 28. Okay? So there you go. So that would be our value for z. So that's how we would have done an example there of solving and writing the equation. You set up the equation, you solve for k, you rewrite the equation with the k. It's going to give you all but one of the variables. You solve for the missing variable. That's direct variation. Okay, now what about inverse variation? So what does that mean? The words are y varies inversely with x. The equation now, instead of y equals k times x, is y equals k divided by x. Okay, I just call it k is called the constant of variation. It also can be written in this manner, like k equals x times y, but usually you'd see it written in this top format. Okay, what does the graph look like? Well, it's going to look kind of like the rational graph with just the one part. Any rational equation that does not go through 0, 0. So it doesn't go through 0, 0. And basically, as x goes up, y goes down. All right, well, let's look at an example for that. So z varies inversely with the square of y. So we're going to write z equals k, and then since it's inversely, it's divided by. So divided by, and then since it said the square of y, we write y squared. Okay, so now we're going to have it with just the variables. Now we're going to substitute in what we know. So notice how it gives us the y and the z. So we substitute both of those in. 13 for the z and 20 for the y. And now we're going to do what we need to do to solve for k. So in this case, we would square the 20. So the 20 squared is 400. And then we're going to get our 400 times 13 to get 5,200. Okay? So that's what we're going to get here for k. Now we rewrite the equation with the k, the 5,200. And now what's going to happen is it's either going to give us the z, we have to find the y, or give us the y, we have to find the z. In this case, it said find z when y is 10, so you plug a 10 in for the y, sorry. 10 squared is 100, so you do 5200 divided by 100, z is 52. Okay? So that would be how we would write the initial equation, solve for k, rewrite it with the k, and then solve for our variable for an inverse variation. Okay? Last but not least is joint variation. So what is joint variation? Y varies jointly with x and z. This means the same thing as y varies directly with x and directly with z. So really it's the same thing as direct variation in the sense that the k is multiplying. It's just it's not multiplying with one variable, it's multiplying with, in this case, two variables, more than one variable, right? So y equals k x z. K is, again, that constant of variation. And we're not going to worry about what this graph would look like because it can get kind of crazy and weird looking. But this is our format. So what would an example look like for that? So z varies jointly with p and q. So first let's write our equation. So we're going to write it with it here. Varies jointly with p and q. And sorry, we have an r here. It should be a z. Okay. Then it's going to give us all of our numbers we solve for k. So 100, plug that in here for r, p, 2, q, 10. Now we need to solve for k. So you do 2 times 10 is 20. Divide 20 on both sides, k is 5. Now we rewrite the equation with the 5, okay, for the k. And now it's going to give us all our values except for 1. So now it says find q, so we don't know the q, which is over here, when r is 60, so you put a 60 in here, and p is 3, so the 3 goes in here. So now what? To solve for q, algebra 1 style, 5 times 3, 15, 60 equals 15q, divide both sides by 15, q equals 4. All right, so let's work a few of these different examples here just so you see kind of how these work, and then you should do the practice. So y varies directly with x. So right away I'm just going to write y equals k times x. All right, and now, just like I had done before, it's going to give me both variables. I need to solve for k. All right, so it says when y is 9, okay, x is negative 15. So we don't know k yet, but we know that that means the x is negative 15. And so now, how do I solve for k? I divide both sides by negative 15. All right, and that's going to give me negative 0.6 there when I do 9 divided by negative 15. All right, so I get k equals negative 0.6. So now I can rewrite my equation with this as the k value. So I'm going to write y equals negative 0.6 x. Okay, what is y? So we don't know y. When x is 21. So negative 0.6 times 21. And now we're just going to do y equals negative 6 times 21. So you can obviously check yourself there as needed. Okay, so 0.6 times 21. So you get 12.6. Remember that was a negative 0.6, so we're going to do negative 12.6. So that would be my y value. Okay, next, suppose x and y vary inversely. Okay, so here we go. Y equals k divided by x. Okay, x is 4 when y is 12. So I'm going to plug a 12 where I see the y. And then I don't know k to start. We never really know that k value to start, unless it just straight up tells it to us, which is going to be rare. So now I get here, I need to solve for k. So what do? I'm going to go times 4 to both sides. When I do that, this cancels. 4 times 12 is 48 equals k. All right, so now I get my equation. Y equals 48 over x. So y equals 48 over x. Now it's going to give me either y or x. I solve for the other one. So what is y when x is 10? So I get 48 divided by 10. Well, 48 divided by 10 is 4.8. So y would equal 4.8. All right, suppose z varies directly. So here we go. Z varies, and then I'm always going to have my k there. Directly with x, that's multiply, and inversely with y, so that's divide. So see, now here we have 3 variables, not just the 2 that we had in questions 1 and 2. Okay, when x is 6, I'm going to plug a 6 in where I see the x, so 6. Again, I'm not going to know k. I don't ever know k to start in general. All right, and then it says y is 2, so I'm going to put a 2 for where y was. And z is 15. I need to solve for k. All right, so I'm going to multiply by 2. So I'm going to multiply by 2. 15 times 2 gives me 30. And then over here it's canceled, so I just get 6 times k. So I'm going to divide both sides by 6. When I do that, 30 divided by 6 is 5. So I get k equals 5. All right, so again, that's not our goal. That's not what we're trying to find, unless it just asks what the constant is. I need to rewrite this equation with the 5 as the k and then be able to solve for what's missing. So z equals, it says find z, so we don't know. When k is 5, because we just found it, what does it say here? X is 4. So you put a 4 where the x was, and it says that y is 9. So you put a 9 where the y was. Now what are we going to do? 4 times 5 is 20, divided by 9. So 20 divided by 9. You could just leave it like that if you'd like. If you want to change it to a decimal, you could feel free to do that too. And that would be our z value. All right, first our last example for the notes. Suppose z varies, and again, anytime you see that, you're going to write that k value jointly with x and y. So that means we're going to multiply with both of them. It says when x is 2, okay, I'll put a 2 here. Y is 3, okay, I'll put a 3 here. And z is 60. So I'm going to put a 60 here. And now I need to solve for k. Well, 2 times 3 is 6, so then I'll just divide by 6 on both sides. So when I do that, I get 10 equals k. So now I'm going to rewrite this equation with the 10 for the k and fill in the ones that I know and find the one that I'm missing. It says find z, so I don't know z, when x is 4 and y is 9. So basically I just need to multiply these through, right? Okay, cool. So 10 times 4 is 40. 40 times 9 is 360. So I'm going to get z equals 360. All right. So these are the notes for the variation module. So make sure from here you try the practice and then check your answer with the key. Hope this helps.